Hey everyone, so today I wanted to make a Linux video about a program called GNU Pass. GNU Pass is a command line Linux password manager that's built on top of GPG, so it's pretty neat and it's pretty useful if you're familiar with the Linux command line. But I have two issues with it that I wanted to discuss with you because I don't think they've been talked about enough. Both of the issues that I wanted to talk about have to do with encryption at rest and how they're handled by GNU Pass and GPG in general. So encryption at rest refers to the idea that your data should be encrypted and unreadable when not in use. The first issue that I have with GNU Pass is how it handles metadata. So when you run Pass, it creates a hidden folder in your home directory, and every time you add a new password, it creates a new encrypted file in the hidden folder to store your password. The issue is that none of the names of the folders or passwords that are stored in this hidden folder are encrypted at all, even though the actual passwords are. This means that if an attacker got access to your computer, they don't actually need your passphrase to know how many passwords you have stored away or what the name of each site in your password vault is. There's actually an extension called PassTomb, which attempts to mitigate the metadata issue in GNU Pass by storing your entire pass vault in a LUKS encrypted container file called a tomb, so that you need your passphrase in order to unlock the tomb anytime you want to view anything about your passwords, including the metadata associated with them. This is a lot better, but we still have another issue that's related to GPG itself. Whether you're using the default pass configuration without tombs or using tombs, GPG keys are what are used to unlock your stored passwords. And GPG actually has a big problem that no one's really talking about when it comes to encrypting your local files. In order to explain the issue that I'm talking about, I'm going to assume that you know how to use GPG, that you have a GPG keyring set up, and that you're using a modern version of GPG higher than version 2.0. In order to demonstrate the issue, we need to examine a specific detail about our GPG keys in our GPG keyring. GPG is kind of stupid, and it doesn't let us actually examine the verbose secret key details without first exporting our secret keys to a file. So let's do the command to export our GPG keyring to a file. Next, let's run the command to list packets that are included in the exported GPG file so that we can see the specific information about it. You'll get a big output with signatures and all kinds of junk in there. But if you scroll down to any one of your secret key packets, we can get a little bit more information. Let's examine the section on iteration and salting. This section actually refers to the encryption algorithm and hashing method that was used to encrypt your GPG passphrase for your GPG private keys. AKA, this is what was used to encrypt the password that you are going to enter every single time that you get prompted for a password prompt in GPG. You'll notice that your key is probably using algorithm number 7 and hashing method number 2. These algorithm numbers are defined in the RFC 4880 standard for PGP message encryption. So if we cross-reference the RFC 4880 standard, we'll find that algorithm number 7 is AES 128 and hashing method number 2 is SHA-1. If you know anything about cryptography, then you'll know that both AES 128 and SHA-1 are computationally fast crypto methods. This means that an attacker can much more effectively perform a brute force attack against these ciphers because it takes less time to compute a single decryption attempt. While using a sufficiently long passphrase helps mitigate the risk of a brute force attempt, SHA-1 is completely deprecated and should never be used as a password hashing algorithm in the modern day. SHA-1 is actually prone to hashing collisions, which makes it significantly easier to brute force than other encryption ciphers. And in the modern day, you should be using a cipher like Argon 2 or something like that for password hashing. Now, you may be asking yourself, who cares? Just configure GPG to use a different cipher for hashing your password, right? But this issue actually runs deeper than you think. Even though GPG does have command line arguments to change the string to key, often abbreviated S2K settings, so that your private keys passphrase can be more protected, these options don't actually work. It's actually ridiculous, since if you try to use any of the S2K options to configure a different cipher suite, GPG will actually ignore your command line options and fall back to using AES 128 and SHA-1 anyway. It won't even give you a warning message that it failed and switched to worse ciphers. Just submit a bug report though, right? They'll fix it. Well, This has actually been an issue on GPG's development tracker since at least 2017, and no one seems to give a shit. As of today, GPG's dev tracker is actually down, so I can't actually tell you if there's been any traction whatsoever, but I'll leave a link to the issue in the video description if you want to check it for yourself. Realistically, what this cipher issue means is that if someone gets a copy of your encrypted GPG keys, your keys may be vulnerable to brute force attacks to discover your passphrase and get access to your password vault. Both the metadata issue and the cipher issue with GNU Pass aren't the end of the world. After all, an attacker has to get access to your computer in order to exploit either issue. That's pretty hard to do, and even then, it's still better than using no encryption at all to store your passwords. But I'd like to leave you with a question. Why put up with these issues? Why not just use a password manager that doesn't expose your metadata in clear text, and that actually uses modern password hashing and encryption algorithms? Even if GPG fixed the S2K issue, which I really doubt at this point, GPG still will probably never get support for truly modern hashing algorithms like Argon 2. These modern algorithms have advanced features like GPU computation resistance to help really keep your passwords secure from brute force attacks. So if you're looking for a free open source password manager, I think at least one thing is clear. Don't use GNU Pass. I would recommend instead using a tool like KeePassXC, which I'll link in the description below. So what do you think? Do you still want to use GNU Pass, or would you rather use a different tool? Tell me in the comments below. Anyway, thanks everyone. Bye.